His name is Clayton, and he'll be doing this talk on application development on the cloud-native platform. So with that, let's give him a big round of applause.
Thank you. After an introduction like that, I hope I don't screw up this nice glow you guys have after you've eaten lunch and all that. So my name is Clayton Coleman. I'm an architect and engineer on Red Hat. I also contribute very heavily to Kubernetes. How about that? Better? I'm one of the reasons sometimes that your PRs don't get merged. So it's not all Tim's fault. It's because I'm taking up Tim's attention someplace else because I'm asking him to solve something really hard. I'm here to talk about a little bit about OpenShift and cloud native development. OpenShift is platform as a service. A little bit better? Yep. So OpenShift is platform as a service. It was created about 4 years ago. It's what we might call like a generation 2 platform as a service. So everybody knows Heroku, right? Heroku came out and said, hey, you're going to build these 12-factor apps, and you're going to push code up to the cloud, and everything's just going to work. And OpenShift came along a little bit after that, and we started to add a little bit to the mix. But about a year and a half ago, as Docker was gaining in popularity, we asked ourselves, well, let's think about what we actually want to build. What's the future of software and infrastructure put together? And 12-factor apps are really cool, but one of the things, working for Red Hat I see all the time is I see these big enterprisey companies that do big enterprisey things with Java, and that doesn't always work that well when you say, well, you just need to log everything to standard out, and they laugh at you because people sometimes need to log 10 gigabytes of data a second to disk or to the network. And so one of the things we thought about is, what do we do to build the right system? How can we rethink platform as a service on top of the current and the next generation of infrastructure in the cloud? And about that time, miracle of miracles, Google decided to open source Kubernetes. And what's more, when they started talking about the patterns that are in Kubernetes, those patterns that Tim and Brian and Dan and Joe were talking about up on stage, those are the patterns that are really critical for actually running cloud native software. And I'm sure if you're in this room, if you've used Kubernetes, there's a lot of concepts that are familiar, and there's some slight tweaks. But to us, it really represented an opportunity to say, how do we build something that works for everyone, not just a few people? So we built OpenShift on top of Kube. So we rewrote OpenShift top to bottom. We built it on top of Kube right about the same time Kubernetes started getting open sourced, or was open sourced. A few of us on the OpenShift team started contributing directly to Kubernetes, and then a bunch of us also started building things on top of Kubernetes, because Kubernetes is great, but we have a deadline, right? We want to rewrite everything that we've done on Kubernetes and ship it to customers, because we want to be out there with something that does make people's lives easier. We don't want to waste time on the old. We want to move to the new. So OpenShift is built on top of Kubernetes. It focuses on two things above and beyond Kubernetes, which is enabling organizations to use Kube. Brian brought up namespaces before. Namespaces is the idea that bunches of people can use the platform at the same time, and everybody works together. And then above and beyond that, not just organizational use of Kubernetes, but the ability to add application development workflows, and not just simple application development workflows, but everything. So why aren't we inside Kube? Well, there's two reasons. One, we actually wanted to have a vibrant ecosystem in Kubernetes. We don't want to jump into the Kubernetes project and say, hey, we're going to throw a whole bunch more code, a whole bunch more reviews, a whole bunch more features before we've had time to work with the people who want to use this, the other people in the community, the open source community. Red Hat is about open source software, and the best communities are big, healthy, vibrant, big tent communities. Just like Docker, we want Kubernetes to be the same way, and it's starting to get there. The second is, we had 50-some engineers at the time, and we said it would be absolutely impossible for Tim to review a single thing if he had 50 engineers from OpenShift nagging him night and day to get something merged in time for Kubernetes 1.0. And we also said, architecturally, the concepts that Brian was bringing up earlier before, we said architecturally we wanted to build systems on top of systems. This wasn't a question that got answered really in the last panel, but one of the reasons that I think Kubernetes is fundamentally different than OpenStack is that Kubernetes is about running software. And we want to run software that runs software on top of something that's really good at running software. And so those patterns, forcing ourselves to think, how do you run something on top of a cloud infrastructure that provides services for that cloud infrastructure, and do it in an open source way was extremely important to us. So if you've used Kube, you might say, is Kube enough? And there's this really smart guy who had this quote. He says, it'd be the right abstraction for 99% of server software running across more than a single machine, a real cloud OS. That guy was me, because I'm really smart. I needed a quote, and I didn't have anything, so I made one up. Today, Kubernetes, the focus is building the right runtime system for applications. And when we were starting to build OpenShift, we said, we've got to have organizational use of Kube. And so we built something on top of Kube that enables the Kubernetes ecosystem to take examples, to sort out the problems that are required to build an ecosystem around Kube. And as a result, we want Kube to be more. We want these things to be part of Kube, but it takes time. And so we focus on the runtime in Kube, and we've built services on top. So you need to make it useful for organizations. What do organizations need? They need authentication, user management, LDAP, groups, teams, fine-grained access control, policy, quotas, admission control, limits, container security templating, high-density edge routing. There was like 30 that I cut off of here. But when someone says, I want to run this software to deploy an application, that's one thing. When someone says, I want to run a software infrastructure system that everyone in my organization can use, there's a larger set of problems. And so we tried to build the basics of those into Kube. Limits, quotas, admission control, these are things we worked on in combination with lots of other people from the community to make sure they were in Kube 1.0. There's a lot more stuff coming. High-density edge routing, just made it into Kube 1.1, and there's a lot of additional features we want to go build on that. Integration with F5 load balancers is something else that we're going to try and get in the community very soon. And most of these pieces, again, are built as services that run on top of Kubernetes. So even though we might say, hey, OpenShift is this system, it's really a set of systems that are built the Kube way to fit into the Kube ecosystem and to offer tools that can be chosen from as we go forward. So that's all the boring stuff, right? That's the, hey, I've got an IT guy who's breathing down my neck because I've got a wide open policy and anybody can run as root on my cluster. It's not a good thing to have, but it's not really that interesting. What really is interesting to us is the next step. So what is the thing that we're trying to build, not just a runtime system, but a system for application development on the cloud? So CI/CD is the thing that a lot of us probably live and breathe. It is the idea that we want to continuously bring changes into our production environments as rapidly as possible, because the more rapidly we can deliver changes, the more often we test things, the more we automate the testing, the more efficient we are at delivering more software. But if you extend that a little bit further and you think about what Kubernetes is a software system. There's lots of things that you can write in software that can run on top of Kubernetes. In fact, I go so far as to say maybe about 99% of the use cases you have when you're thinking about, well, I need to go run this job to go build unit tests. And instead of having to build a system to run a very specific unit test job, I want to very simply script the Linux software I'm familiar with to go do that. And there's lots of hard problems in this. Like, this isn't an attempt to say that these problems are insoluble in the existing systems. But the vision, where we want to be with Kubernetes, is we want to be an ecosystem of flexible infrastructure, cloud-native flexible infrastructure, that you can run normal, iterative development on, that you can leverage for testing and builds and jobs and background tasks and all that. One place that you can go, and that idea that you can do this is, the real world is that there's lots of these flows. There's lots of tools, there's lots of layers. There's no magic bullet, right? Nobody's going to come out and say, hey, this is the one system that's going to solve every one of your problems. But we want to say, how can we make Kubernetes better at integrating these pieces and offer options that make sense for people to work along? So I'll show a demo in a few minutes. But the idea being that the simplest possible workflow you can possibly describe, you have source code, you get a build. And because this is Kubernetes, and this is the real important part, because we're building images that run on Docker, we've started to buy into the mindset of immutable infrastructure, right? We build these images and we have to deploy them. But it's not enough just to build an image once, right? What happens when shell shock comes out? What happens when somebody needs to tweak a configuration change? And there's no one-size-fits-all for how this flow will work. But there are a bunch of fundamental patterns that we're all familiar with. So the next one is something that I'm sure a lot of people who've worked on Kubernetes will say. You build a branch in source code, It runs through the Kubernetes CI system. Somebody makes the decision to automatically merge it, and then it gets included in the next builds that we do. Again, a similar pattern. These are given the same color, and they're roughly lined up because they're the same concept. You have inputs. You want to run a process on them. You want to do something to them. And then you want to make it available for others. So deploying something to production versus taking a merged image and pushing it to a branch, pushing this to the master branch are similar concepts. And there's one level further here, which is I might have my source code, and I might use a process of integration to build a flow that helps me build my source code more efficiently. But everyone here has probably dealt with libraries. So how do those libraries get built? So broaden the thinking for a moment. My source code isn't really that different from a Maven jar that was built and pushed to Nexus. It's not much different from a gem that goes on Ruby gems. The difference is that it's very likely that that first build depends on the versions and the software, and it needs to be able to access that in a reliable manner. And sometimes you work in firewalled environments. And doing all these builds is expensive. And say you need to go and understand what's running in your organizational environment, what libraries you're actually using in production at any one point in time. So these are all variants of the same problem, which is an operator and a developer, when you're building and maintaining software, you need to know what is actually being used and what's actually out there in the world. And there's one more wrinkle. Obviously, I talked about shell shock. Sometimes the input to a build is itself the result of another build, a little bit like a library. And so if you think about all of these flows across an organization that's running on top of Kubernetes, the first step is usually, well, I might just rebuild my application, but occasionally I have to rebuild base images. And sometimes I have to rebuild the images to get the base. And there might be a team that maintains those images and make those available to me. So with OpenShift, we tried to start from the mindset of, we want to start building tools that run in a Kubernetes ecosystem to let you do Docker image builds. We let you push images and reference those images easily, because fundamentally everything in Kubernetes is running an image. And we want to make it easy to deploy those images to production. So some of this predates where Kubernetes 1.1 is. But the deployment concept is the idea that after I've said the PHP 5.5 stable image has been updated, that all the things that depend on the system, whether they're builds or deployments, can react to that automatically. And there's always places where this might not be an automated flow. But for the vast majority of simple applications, this flow is enough to say, yep, I applied a security update in my base image, and it flowed out to the system. If there was a failure, sometimes you might need to stop. If you're an administrator and you don't like the current version of PHP 5.5 stable, you might change it to point to the next patch release. And that version is organizational. The Docker Hub isn't the only person that can tell you what the stable version of PHP is. You and your organization might need to determine that for themselves. So rather than describing these concepts in a very vague and ultimately fruitless approach without a lot of pictures, I'd prefer to just show how OpenShift works. So OpenShift, today we announced OpenShift 3.1. And OpenShift 3.1 is the second release in the open source version of OpenShift. We call OpenShift 1.1 because we like to confuse people. So I am going to start up an instance of OpenShift on my local system. This is OpenShift plus Kubernetes, all running in a single container, running in Docker. So obviously, if you have Docker and it's a great way to deploy things, then you also ask the question, well, why don't I just run all of my infrastructure inside of Docker? And then you get in the question, well, who manages the infrastructure? Won't worry about that now, but the idea of, on my system, I just pulled down and ran a Docker image, and it contained this whole platform as a service. It contained Kubernetes, the node. It's able to reach out and talk to the hardware on the system. Now that that's up, I can access the web console. And the web console will log me in after I and so I'll log into the web console as a demo user that I just created in the background. I gave access. So OpenShift is a Kubernetes system and adds a few things on top. Our UI is mostly the idea that these flows are integrated. They need to be thought of together. And so I'm running a Docker registry that's integrated with OpenShift. It's actually running on top of OpenShift. It's running in a container. It's being deployed the same way that everything else is. It benefits from everything that Kubernetes can offer like resource constraints, controls, access to the host system. It's secured. I also run a router. So I talked about high density edge load balancing. If nobody can access your web applications from outside of your firewall, it's not much of a web application platform. So OpenShift has worked with the upstream Kube community, the ingress resource and the load balancing that's there. These ideas are things that in OpenShift we're really excited to see make it into Kube, and we want to keep evolving. And OpenShift is a vehicle for delivering these to developers. So I'm going to go and I'm going to create a bunch of templates. You saw a whole bunch of stuff streamed down. Tim talked about how things are fast and how that's really important. We absolutely agree with that. We want the system to feel very responsive. So you tell the system what you want, and the system works to make it happen. I've done a bunch of setup here, but I haven't actually done anything as a user. So I've got these pods running on my cluster. These are more infrastructure pods. But as a developer, I often want to do things like log in and deploy applications that have been pre-canned for me. So another concept that we've talked about in the upstream Kubernetes community, and that the Deis guys have Helm, like these ideas that I want to pre-can an application and deploy it at the push of a button is something we take really seriously. As developers, when we want to get familiar with a platform, we often want to start off by using an example and then iterating further. And then when you expand that, you say, well, what's really the difference between a template for running MySQL and my production MySQL application? Should be config, should be declarative, should be something that if I need to tweak it, I can take it and check it into source code and then roll it out. So I'm going to start here, and this is a template. I'm going to deploy a Cake PHP MySQL example. And this is using some of the concepts in Kube, and it's using some of the concepts in OpenShift. It's going to generate a bunch of security information and generate a final deployment. Uh-oh. Well, this is what happens with running live demos. Looks like we found that bug too late. I'm going to go retry that. Uh-oh. Yeah, right. Oh, that's right. I didn't switch projects. Oh, that's what happens. Yeah, so unfortunately, I did the thing I shouldn't do, which is not pay attention to what I'm actually demoing. So I created a new namespace there. Oh, man. Tough crowd. So I created a new project, and it appropriately warned me that it was unable to do anything useful for me. But this is somewhat still salvageable. What's going on actually in the background is I created a big template for an application. There's a lot of pieces there, but one of those pieces is a build that's going to generate an image. I didn't actually have that image or any of the inputs to the image on my system before I created it. I said, I want to use a base image that was previously imported into the system, and for PHP that has everything that PHP needs to run, as well as a little bit of glue code in Bash and scripting that's going to take the source code I give it and deploy it the correct way. And this is a flow that we call source to image. It's something that, taking the idea of, rather than developers making all the decisions about their Docker files, which is totally valuable, OpenShift will let you run Docker builds on the infrastructure as well. But when as an administrator you want to control what's going into production, or as the central team for a large organization, it's like, here's the version of PHP you should use. This is tuned, don't touch it. Here's the version of MySQL you should use. This is going to work well in a cluster, don't touch it. You can offer images that people can consume. I created the request to build something, and this build's going to run in the background until it completes. So you'll see the logs of the build. It's going to download the source. And when the build's done, it's going to push to an image stream that I defined earlier. And the image stream is just a name. I said, I want my application. Let's see where this is pushing to. The output of this build is going to go to demo, which is my current project, Cake PHP MySQL example latest. But I could set that all up at front because I chose two names. I chose something I wanted to deploy, something I wanted to build. I defined it all at the same time. Everything ran in the system, and eventually this build will complete. Unfortunately, this is the first time I've pushed an image to this particular registry because I just spun it up new, so it's got to push the base layers. On subsequent pushes, just like the benefit from repeated Docker builds, you don't have to push anything. So I don't know if I'm going to be able to debug this generic failure here. Let's see. So on the command line, I'm just going to go in and take a look at what actually got created. So it did not create a deployment for my application. So I'm going to totally hope that this works. And I am going to say that I want to build a new application from I'm going to build a new application that looks at the image that I've just created and uses it to build, to figure out what it actually needs to go deploy. So it should be almost done now that we've pushed a lot of the base layers. It's a good thing this failed so I can go debug it while it's taking forever to build. So there's a lot of performance improvements that Red Hat and members of the OpenShift team have actually worked on in the upstream Docker community, ways of making it more efficient to push. And so it's really important to us that Docker and Kubernetes work for all these workflows and everybody just benefits. So I successfully pushed the image. It's been pushed to the internal registry. And as an application user, I actually have access to that image metadata. So I'm going to tell it to build a new application from it. And it created the cake.php MySQL example app off of it. Now, unfortunately, because of the lack of some of the metadata that was in that template, that little bit of the application isn't going to quite fit right. But if I scale this up to 3, and then maybe I can just go ahead and see if I can get into this application. So, oh, that's bad. So I've scaled up in the background. I'm going to create a service. I'm going to actually give it the right name this time. I thought I gave it the right name. Yeah. So my cake.php MySQL example app is now deployed. It may not actually show up when I go view it, but that's the risk I'll take. And the OpenShift console is really not about hiding. Oh, I put the port in. So the cake.php application is supposed to show a little counter down here, because when I created the template, it had the database and the application source code all wired together. But in general, the idea of we're creating pieces of software that can be easily deployed and iterated on. When you capture something that works, you can build a template out of it. You can build flows of software that run through the system. So you just saw me build an image on demand. I can build and rebuild, tag in new images, and have those flow through the system. And for the most part, if you're dealing with small, simple applications that are individually separated, changes flow through the system automatically. When you start building more complex flows, you have that control over the system so that you can build deeper integrations. A lot of the things that I won't show today are things like applications that have multiple containers both flowing together. A deployment happens when one image changes. And OpenShift in general tries to bridge this gap between the very simple and the very complex, and to be an aspirational goal for where we want Kube to go in the future of. We want Kube to be a place where you build, manage, deploy, test, validate, and finally roll out applications. Not just using it for a final target, someplace that your app goes to probably die and then get rebooted automatically over and over and over and over again. But instead, a part of a living system, right? It's not just about the software that we start with, it's about the process that we build this software. So that is my talk today. Definitely, if you have things that you're looking for in the application space, please come talk to us. We'll be up in the Presidia room as well. Our goal is to make Kube the best runtime environment for applications, but also to make it the best place to iteratively develop and manage applications. Thank you.
We do have time for a couple of questions. If you can take those to the side, I'll unhook you here.
No questions? All right.
Wait a minute, no questions? Here's questions right here. There you go.
So the question was, are there plans to support OpenShift? So OpenShift Origin does run on all the different operating systems. OpenShift Enterprise is supported on Red Hat systems. That's basically kind of the Red Hat way, unfortunately. But you can run, if you go to the open source community, the Ansible installer and many of those things will run on those different platforms. As we move into the more of the containerized infrastructure, OpenShift Origin is actually a target that you can deploy from using the same install stuff that you would use for the production systems. We actually have a fair number of people who run on Ubuntu. And there's most of the bugs that come up are mismatches between software versions. So there's nothing fundamentally Red Hat specific in OpenShift itself. It's how we work at the Docker and the kernel layer to make sure that everything top to bottom performs well and is well tuned.